Okay, linear quadratic systems. So I apologize for not being there today. This is an unplanned absence, but this is not an overly difficult topic because it's something that you guys have done before. So the only difference is instead of doing just linear systems where we solve where a linear line meets another linear line, so we have points of intersection, we're now looking at linear and quadratic lines. So the first thing that we're going to look at is solving a linear quadratic equation just means finds the point of intersection or the points of intersection. So the first thing you want to do is set the equations equal to one another and then find your x values. It's exactly the same as finding your roots, so you factor or use quadratic formula. The second thing you do is sub those values back in to find your y values. So how many different ways can we do this? Well, if you think about it, if it's the exact same as the roots, then it should have the exact same answers. So we've got one solution, zero solutions, and no solutions. Zero solutions happens when the linear line is below the vertex, or if the parabola had a maximum, it would be above the vertex. One solution is when the line just touches at one point. So it's not necessarily at the vertex in this case, but it's touching at one point. It's almost like a tangent, if you've heard that word before. A tangent mimics a line, and it touches at one point. That's what's happening here. And two solutions is just the most common one, where the line intersects twice. So solve the following system. So what we have is y equals 2x minus 1 and negative x squared plus 6x minus 1. The first thing we want to do is set the equations equal to each other, so the two y values, and solve for x. Now when we do that, I've gone ahead and done the whole thing for you here because it's just a quick factor. We get 2x minus 1, which is from the first equation, equals negative x squared plus 6x minus 1. So that's y equals y. Then we have x squared minus 4x equals 0. Because the 1's cancel out, we bring the x squared over, we get the negative 4x. Factor and solve. Now the next thing you have to do is then sub in and find your y values. And that's literally just taking x equals 0, subbing in, taking x equals 4, and subbing in. So you get your y values of negative 1 and 7, and then put a therefore statement. So the points of intersection are 0, negative 1, and 4, 7. This is not an or situation. Those are both points of intersection. If you need to pause the video, you can, but I've provided the note with you, so you shouldn't really need to copy anything. Solving this one, so solve this system. So we've got 3x squared plus 12x plus 14 equals 2x minus y minus 8. Or sorry, those are your two equations, equals 0. In this case, you have to rearrange one of the equations because this one is not equal to y. That's fairly quick. So you just rearrange the second equation. So this is now what we have. You're going to then set them equal to each other. So this equals that. Now I'm going to put everything on one side, and then I'm going to cheat a little bit because I know the answer. But looking at this, I couldn't factor that really quickly in my head. So I'm going to use the discriminant just to see. You're probably better off using the quadratic formula because if there are answers, then you're wasting your time by doing this. But it is part of the quadratic formula anyway, so you could just plug in your answer underneath the square root sign. But I recognize that I've got a negative, and that should be 164, not 264. 1. On your note, you probably want to change that to a 1. But it doesn't matter because it's negative anyways, so negative 1 or negative 2 doesn't really make a difference. It means that we're going to have no solutions because we have a negative under our square root. We can't have any answers. Okay, and now a word problem. So we've got a punter. So this is for those of you that don't know, this is a football player that kicks the ball. Doesn't really matter. It's starting at a point of 0.8. The height of the approaching blocker, so someone's trying to block the kick, is modeled by this linear equation. And can they block it? Now, what you have to recognize is that you're going to solve the equation the same way we did. But you're going to get to this point, then you're going to have to use a quadratic formula because probably none of you can factor that and get these repeating numbers. So we're going to get this, and then we're going to make a quick sketch, because this answer, although it doesn't really make sense to block something 3.5, almost 4 seconds later, it could be true. But when I make a quick sketch, now I know my lines aren't great here, you notice that one of the points of intersection is underneath 0. So that would mean the person is blocking the ball under the ground, and it's after it's already hit the ground. So that doesn't make any sense. So this is our only solution. So this one's inadmissible. This is our only solution. And make our little therefore statement. So by making a sketch, you can see that only one of them makes sense, and that they would block the ball after 0.18 seconds. Okay, I provided 6 questions here. If you finish early, you want to start reviewing, because we're not going to have an official review period for this. We're going to do our assignment tomorrow. We would have done it today, but I wasn't there to hand it out, and I want to be there for that. Okay, you might do it tomorrow without me anyways. It depends if I'm back. Okay, good luck.